There is a planet out there with an ocean, not of water, but of oxygen. A sea of free molecular oxygen like the kind that we breathe here on Earth, but much, much thicker. And it's thick enough that if you were to go to this planet, you would drown in oxygen. But which planet is it? Well, it's not Mars, even though it's a very popular guess. And it's also not Jupiter or Neptune or Uranus. And while it may surprise you, it's actually not even Saturn. But there's definitely something going on with Saturn's atmosphere. In 2010, NASA's Cassini spacecraft discovered that Saturn's upper atmosphere contains more oxygen than any other planet in the solar system except Earth, with the possible exception of our dear old moon. Now, what's really strange about this is that scientists cannot explain why so much oxygen is present in Saturn's atmosphere. The most likely source appears to be ring rain, but they don't know how rings of ice could possibly create such a dense sea of oxygen. So there's no shortage of wild ideas floating around out there regarding where this oxygen might be coming from. Some have suggested that it could be evidence of life, or at least some sort of prebiotic molecule. Others have hypothesized that it could have come from a long extinct ocean on Saturn. But perhaps the most exciting possibility is that Saturn's atmosphere is more like Earth's than we think. So in today's video, we're going to dive into the discovery of this mysterious oxygen and examine some of the craziest theories out there regarding where it might have come from. This is the space race. Now, it's important to state that the exact chemical composition of Saturn has been known for quite a while. We've known ever since the Voyager missions back in the 80s that Saturn's atmosphere is mostly hydrogen and helium, just like Jupiter and Neptune. These are all gas giants, after all, but during the Voyager flybys, scientists noticed something unexpected. They found traces of ammonia ice clouds in Saturn's atmosphere, which was odd because they weren't expecting to see anything more complex than hydrogen and helium. Scientists went into the Voyager data and identified small amounts of methane, ethane, propane, and butane in Saturn's atmosphere as well. So when Cassini arrived at Saturn, one of its main objectives was to analyze the chemical composition of the atmosphere in greater detail. And boy, did it deliver! Between 2004 and 2017, Cassini measured the ultraviolet spectrum of light filtering through Saturn's atmosphere, which allowed scientists to determine the abundance of different molecules present in the gas giant's upper layers. In the process, Cassini identified the first definitive evidence of oxygen on another planet besides Earth and the Moon. In fact, the amount of oxygen in Saturn's atmosphere is more than 3 times higher than the amount in Earth's. Now, the issue is that scientists don't really know where all that oxygen came from. Saturn's interior is mostly hydrogen and helium, the same stuff that makes up its atmosphere. And we know that these elements don't contain any oxygen at all. What's more, oxygen is a very reactive element, and it tends to bond with other elements pretty quickly. So it should have combined with something else long ago, theoretically making it impossible for large quantities of free molecular oxygen to exist on planets like Saturn. So, where did all that oxygen come from? Well, the leading hypothesis among astronomers is that it comes from Saturn's rings. Scientists think that the rings are mostly made of water ice, which of course contains both hydrogen and oxygen. And because the ice crystals are so small, they can be blown away by Saturn's winds. Some of these ice crystals reach an altitude of 1,000 kilometers above the planet's surface, where the sun's ultraviolet radiation breaks them down into molecular oxygen. And then this oxygen is carried further up into Saturn's atmosphere by winds blowing at 180 meters per second. But there's a problem with this hypothesis. If this were true, we would expect to find more than just oxygen at these high altitudes. Unfortunately, the ultraviolet cameras on board Cassini were not equipped to detect most molecules. So while they confirmed that there was a lot of oxygen at these high altitudes, they couldn't tell what else was present. But in 2013, Cassini got a helping hand from an unlikely source. The legendary guitarist and composer Brian May. May also holds a PhD in astrophysics from Imperial College London, and he has been heavily involved in several space projects over the years. He helped build the instrument that took the famous picture of the Queen of Clubs, for example. So in 2013, May teamed up with scientists from the University of Berlin to use a spectrometer to analyze light reflected from Saturn's rings. And sure enough, they discovered traces of oxygen in the rings themselves. The researchers concluded that the oxygen probably originated from water vapor from deep within Saturn that rose up through the planet's interior and condensed on the cold surfaces of the rings. Then, when the ice reaches a certain size, the electrostatic forces cause it to become electrically charged. And finally, the charges in the ice cause the oxygen atoms to split off and float away into the atmosphere. But while this seems to explain where the oxygen is coming from, it doesn't necessarily explain how it's getting into the atmosphere. You see, the rings are opaque only about 100 meters above Saturn's surface, meaning that anything past that altitude gets dispersed and eventually reaches the planet's atmosphere. But Saturn's rings are miles wide and hundreds of kilometers thick, and they extend almost all the way to the planet's equator, so they span almost 275,000 kilometers across. And all that distance means that there is a lot of energy involved in moving all that ice. Not to mention that the particles in the rings orbit Saturn at around 9 kilometers per second, meaning that all that momentum has to be transferred to the atmosphere as well. So if all the oxygen is coming from the rings, there should be a noticeable change in Saturn's atmosphere where the rings end, just like there should be a sonic boom when an object passes the sound barrier. But Cassini never detected anything of the sort, leading some scientists to believe that there must be more to Saturn's oxygen than meets the eye. It's possible that the oxygen is created in some way on Saturn's surface, either through geological activity or biological processes. And while it's highly unlikely, it's theoretically possible that Saturn had an ocean on its surface in the past. If that's the case, then all the oxygen we're seeing now could simply be a remnant of that ancient ocean. It's unlikely, but not impossible. After all, Saturn formed early in the solar system as history when the Sun was surrounded by a disk of dust and gas. Gravity caused this material to collapse and form the planet's core, which then accreted the rest of the mass. If it accreted material from the disk that contained oxygen, it could have led to an ocean on the surface. And it's possible that if the mantle continues to generate heat, it could still have an ocean beneath the surface. This would also explain why the atmosphere has so many hydrocarbons like methane, ethane, and propane. But what's really exciting is that it could also mean that Saturn is more like Earth than we think. You see, the only reason why Earth has an atmosphere and Saturn doesn't is because Earth has a powerful magnetic field that traps the gases in our atmosphere and prevents them from escaping into space. Saturn's magnetic field is about 578 times weaker than Earth's, meaning that any oxygen it had would have long since dissipated into space. But what if Saturn used to have a stronger magnetic field? Maybe it was strong enough to hold onto a denser atmosphere, including oxygen. Maybe it was strong enough to support an ocean of oxygen. Could it be possible that Saturn was once a lot like Earth? Well, maybe. Saturn's core is thought to be mostly iron and nickel, similar to Earth's core. And it is possible that it could have generated a magnetic field comparable to Earth's early in its history. Maybe it lost its magnetic field as it cooled and the dynamo effect weakened. Or maybe the magnetic field was destroyed by a massive storm, something that happens on Jupiter and Neptune. In fact, it is possible that the oxygen we see on Saturn today is evidence of a recent storm that stripped away part of its atmosphere. If Saturn did have an ocean of oxygen in the past, it could have been big enough to support life as we know it. But if it was destroyed by a magnetic storm, then there wouldn't be any life on Saturn today. Unfortunately, we may never know if this is true. But one thing's for sure, Saturn's atmosphere is more like Earth's than we think. And the answer to this mystery could rewrite everything we know about our solar system and the universe itself. So what do you think? How do you think Saturn is producing all that oxygen? And do you think it could have supported life in the past? Let us know your theories in the comments below. And as always, if you want to learn more about the amazing discoveries being made in our solar system and beyond, make sure to subscribe for more updates. There's a lot more to come.